Good day and welcome to the online class for our subject General Physics 1. In the previous video, we've talked about vectors and its properties. In this video, we are going to solve some problems involving resultant vectors using the triangle law. So the triangle law states that if we have two vectors A and B, and we place vector B, the tail of vector B, on the tip of vector A, the resultant vector is the vector that completes the triangle, which is drawn from the tail of vector A to the tip of vector B. So since in triangle law, our vectors form a triangle, we are going to discuss first some laws that is useful for us, that will be useful for us in determining the resultant vector of two vectors using the triangle law. The first law for triangle that we are going to discuss is the law of sines. So if we have a triangle ABC with sides small letters A, B, C, and the opposite angles are angle A, B, C respectively, law of sines states that the ratio of the side to the sine function of the angle opposite to each side is equal. That is, A all over sine of angle A equals side B all over sine of angle B, and also equal to side C all over sine of angle C. The second law that we are going to use is the law of cosines. Still, we have a triangle ABC with sides small letter ABC and opposite angles AB and C respectively. Law of sines state that the square of the side of one side is equal to the sum of the square of the two other sides, minus twice the product of the sides, and the cosine function of this angle opposite the unknown side, or the angle that is adjacent, or the included angle of the two adjacent sides B and C. If you are determining for side B, the length of side B, and for angle C, it's the same. Okay, one way to remember it is that the square of one side equals the sum of two other sides minus twice the product of the two sides, which is also the squared one here, and then times the cosine of the angle that is opposite the side of the unknown, or this angle is also the included angle of the two adjacent sides. So law of sines and law of cosines will be very helpful for us, since in determining the resultant vectors of two vectors using the triangle law, we are dealing with triangles. So let's move on to the example. The figure below show two position vectors of magnitudes for vector A, 18.3 meters, and for vector B, 30.5 meters. Determine the resultant vector R using the triangle law. So solution, by definition of the triangle law, if we place vector B on the tip of vector A, if we place the tail of vector B on the tip of vector A, then we can form a triangle by adding the resultant vector. The resultant vector completes the triangle, which is drawn from the tail of A to the tip of B. So here we form a triangle where one side is 18.3 meters and the other side is 30.5 meters. Then we have the unknown side, which is the magnitude of vector r, the resultant vector. We are looking for the magnitude and also the direction of vector r. So using law of cosines, we know that to find the length of one side, we need to find, or we should determine the length of the other two sides, which is for this problem already given. So we have the 18.3, 13.5, because the side corresponding to the resultant vector r is unknown. So we need the two other sides which are already given. And of course, we also need the angle that is opposite the unknown side. So 18.3 and 30.5 are already given. To apply cosine law, we need to look first for the angle, the included angle between 18.3 and 30.5. So how do we do that? I will first extend the horizontal line or the reference line for vector B. And since the reference line for vector A is also a horizontal line, I can say that these two lines are parallel. Okay. And if we have two parallel lines and one intersecting line, we know that alternate interior angles are equal. That is, if this angle 30 degrees, then this angle is also 30 degrees. Right? Next, I will draw a line perpendicular to the reference line. Yeah, here. So I will draw a line perpendicular. And because this is perpendicular, the angle between them is 90 degrees. Also, on the right side, since this is also 90 degrees, and we already have 70 degrees from the reference line to vector B, then from vector B to the perpendicular line, we have 20 degrees to make it perpendicular. Therefore, from vector B to vector A, the total angle is 30 plus 90 plus 20, which is equal to 140 degrees. That is the included angle between sides 18.3 and side 30.5 meters. So I'll erase it to make it clear. Sorry. The angle opposite to vector r is 140 degrees. Okay, we already have the length of the two other sides and the angle opposite to the unknown side. Therefore, by law of sines, we can now determine the magnitude of r. 18.3 squared plus 30.5 squared. The square, the sum of the squares of the other side, minus twice the product of the other sides and the cosine function of the side or the angle opposite the unknown side, or cosine 140. Okay, heads up, you should have a scientific calculator because cosine 140 is very hard to, is not a special angle. So simplifying this expression, we have 18, using the calculator, 18.3 squared is 304.89. 30.5 squared is 930.25. Okay, I'll just fix it. Yes. Minus this whole product is equal to negative 855.14 rounded up to two decimal places. Simplifying further, we get r squared equals 2120.28, and we need to take the square root of both sides to get r, or the magnitude of r, be equal to, okay, I'm sorry, I forgot to use the magnitude sign. So the magnitude of vector r is equal to 46.05 meters. Sorry. We already got the magnitude. To complete the vector, we need to find the direction, okay? And to find the direction, we need to get this angle. The direction should always be with respect to the reference line or the horizontal line. So the actual direction of r is from the vector r to the reference line. However, we know that from the reference line to vector A, as you can see in the figure, that is already 30 degrees. So I only need to get, let's name this angle alpha. So which is the angle between vector A and vector R. And to do that, I will apply the sine law. Sine law states that one side divided by the sine of its function is equal to the other side divided by the sine of its opposite angle. So I will use, since I've already known the value of r and its opposite angle 140, I would use r and 140. So r divided by sine of 140 is equal to the side opposite angle alpha here is 30.5. So 30.5 divided by sine of angle alpha. Sorry, let's change r to, what's our value for r? 46.05. Okay, cross multiplication, I get sine of alpha here is equal to 30.5 times sine of angle 140 divided by 46.05. Sine of angle alpha is equal to, okay, let me get my calculator. 30.5 times sine of angle 140 divided by 46.05, I get 0.43. And to get angle alpha, we need to inverse the sine function. Again, using your calculator, we get, excuse me, 25.47 degrees. So 25.47 is not the direction of angle r, it is only the angle between vector r and vector A. So here, instead, the direction of angle r is 25.47 degrees plus the 30 degrees to make it based on the reference horizontal line. So we need to add. Therefore, the direction of r of vector r is equal to 30 plus alpha, which is 25.47 degrees, which is equal to 55.47 degrees. Therefore, to complete, our vector r is equal to 46.05 meters. Vector r is the resultant vector at 55.46 degrees above the horizontal axis. So this is our final answer for the resultant vector. So that is determining a resultant vector using the triangle law. If you have any questions, feel free to contact me, message me on group chat, or comment on the post at the Google Classroom. Thank you and happy learning.